Okay, so we are going to look at Chapter 4 out of your 9th textbook, exercise 4.13, so 4.13. And it reads, a rifle is aimed horizontally at a target 50 meters away. The bullet hits the target 2 centimeters below the aim point. What was the bullet's flight time? And what was the bullet's speed as it left the barrel? So what was the muzzle velocity? All right, so let's start our process. The object we're interested in is the bullet. Now, I'm going to remind you, I'll try to remember to do it throughout the whole problem. Don't forget to pause. Make your list. Pause, do your origins. Pause, do the initial and final, and then test your information with my information. And practice this in an active way instead of just watching me run through a problem. Practice it actively and see how you do. Okay, what is the initial and the final? What starts the motion? What ends the motion? Well, it's when the bullet leaves the gun. And it ends when the bullet hits the target. The moment the bullet hits the target, I don't care anymore. So let's draw our picture. Here's our bullet. We're told it's fired purely horizontally. And I need to identify two origins. I'm going to say that my horizontal origin is equal to 0 at the location of the bullet. And my vertical origin, x, vertical, can't read that. Is also equal to 0. Keeping in mind that this is a two-dimensional projectile motion problem, because that gives us some implied information. All right, two origins, two dimensions, two lists of information. So horizontally, I have an initial position horizontal, a final position horizontal, an initial velocity horizontal, final velocity horizontal, acceleration horizontal, and time of the total motion, independent of direction. And vertically, I have an initial vertical position, a final vertical position, an initial vertical velocity, final vertical velocity, vertical acceleration, and time as well. So what are the values that I know or can be implied from the problem? For horizontal, well, the bullet starts at 0. My final position, go back to the problem. It says the target is 50 meters away, so it does end at 50 meters. So the target's out here at 50 meters. My initial horizontal velocity is not given. However, I'm in two-dimensional projectile motion, so I know my acceleration is 0. So I don't know the final horizontal velocity, but I do know that there is a single value for horizontal velocity. It doesn't change as time goes on. And I don't know the time of the motion. All right, vertical list. Try to pause, make your vertical list, and then see if it matches. So it initially is at 0. That's where I set the vertical origin where the bullet took off. Final vertical velocity. It says it lands 2 centimeters below the aim point. So it was aim. If I went purely horizontal, it would end at 0. But it ended 2 centimeters below 0, which is a negative, that's important, 0.02 meters. 2 centimeters is 0.02 meters. My initial velocity vertically, well, it's purely horizontal. I don't know what it is, but I know vertically there's nothing. So my initial vertical velocity will be 0. I don't know my final vertical velocity. I am in the case of two-dimensional projectile motion, so I'm in free fall. So my acceleration is negative 9.8 meters per second squared. I don't know my time. So there's my vertical list. So part A asks us, what was the bullet's flight time? Part A wants to know the time of flight. Now, I could go after part A, either in the horizontal or in the vertical direction. Time is, in fact, in both of them. So typically, it's the vertical information that I have more of in relationship to time. I guess I shouldn't say typically. Sometimes I use the horizontal information to get time. But because I don't know the horizontal velocity, I'm not going to be able to do that. But I should be able to get time from vertical information. So our position relationship, which has initial and final position, initial velocity, and acceleration, is only missing time, which is what I want. So x final negative 0.02 is equal to x initial 0 plus v initial 0 times time, whatever that is, plus 1/2 negative 9.8 times time squared. So I know that negative 0.02 is equal to negative 4.9 t squared. So 0.02 divided by 4.9, take the square root, we find our time is equal to 0.064 seconds. 0.064 seconds. So here is part A. All right, part B says, what was the bullet's speed as it left the gun? So it doesn't really care what the direction is. It's horizontal, it's positive, but it doesn't matter. But it does want to know its speed, which is the magnitude of the velocity horizontal. So we want to determine the initial velocity, and in this case, it's horizontal. So I have my initial and final position, x final is equal to x initial plus v initial t plus 1/2 at squared. No acceleration in this one, so that's going away. X final is 50 equals 0 plus v horizontal times my time of 0.064. And I find that v horizontal is equal to 783 meters per second. And I'm just going to confirm that. Yes. All right, so this is a practice problem of an object leaving horizontally. Good job.